single Reaper drone just circled above the Black Sea for 27 hours straight, its cameras locked on every move of a Russian surface group. Total cost of that sortie? About $3,000 in fuel. The cruiser below, worth a cool $1 billion, never even saw the drone's laser spot that could have guided a ship-killing salvo. Pilots fast asleep in Nevada pressed a few keys. Moscow's fleet spent the night zigzagging in panic. If that sounds like something pulled straight from a sci-fi blockbuster, blink again. The age of the fighter pilot, as we've known it, is already ending. And it's autonomous aircraft, not hotshot aces, that are writing the new, often brutal rules of air combat. The problem for 70 long years, air forces around the globe chased an ever costlier dream. Build a manned aircraft so fast, so stealthy, so jam-proof that it could survive inside today's missile-drenched skies. It was a noble pursuit, fueled by daring pilots and cutting-edge engineering. But the bill for that dream is now measured not in millions but in hundreds of millions per airframe. An F-35A, for instance, sets the U.S. Air Force back around $110 million. A single Eurofighter tops $120 million, and that sticker price. That's before you even start adding the $40,000 flight hour. The dedicated tankers needed to keep it aloft, the electronic warfare escorts shielding it, and the pilot training pipeline that burns through $4 million per trainee. It's an astronomical sum, a testament to technological ambition, but also a growing strategic liability. Worse still, the human body has become the ultimate limiting factor. Modern airframes, marvels of engineering, can pull 15 Gs with ease, yet pilots black out at a mere 9. Fatigue sets in, sometimes subtly, sometimes brutally, after 8-hour missions, dulling senses and slowing reflexes. Reaction times, even for the best, plateau at around 0.3 seconds, an eternity when an incoming missile is screaming towards you at Mach 3. Every single sortie risks a highly trained, irreplaceable life, and beyond the human cost, there's national prestige at stake. Lose a pilot over hostile territory and you don't just lose an aircraft. You get a hostage video, a potential prisoner swap, and a propaganda storm that can ripple through global headlines for weeks. It's a political, moral, and strategic nightmare. Traditional air forces are, in effect, betting their entire warfighting strategy on a handful of exquisite, fragile, and astronomically expensive nodes. These are the crown jewels of their military, but they're also incredibly vulnerable. And guess what? Adversaries have noticed. Cheap surface-to-air missiles, drone jammers, and networked radars are proliferating at the speed of Amazon Prime, making the skies a far more dangerous place for those billion-dollar assets. The arithmetic here is brutal, almost laughably lopsided. Do you defend a battle space with $120 million jets? Or do you attack it with $15,000 drones that you can literally 3D print in a shipping container? One side risks national treasure, irreplaceable pilots, and global humiliation. The other risks spare parts, easily replaced machines, and a few hours of manufacturing time. Something had to give, didn't it? And it already has. This isn't just about economic efficiency, it's about shifting the very definition of what constitutes a credible threat, allowing relatively unsophisticated adversaries to target highly advanced military assets. The digital wingman arrives. Meet the Air Force's next procurement buzzword, destined to become a household name: Collaborative Combat Aircraft, or CCA. Think of a CCA as Siri with sidewinders, an unmanned jet roughly the size of a trainer aircraft, designed to fly, fight, and if necessary, die at a human pilot's precise say-so. The official requirement? Deliver 1,000 of these aircraft before 2030, each with a flyaway cost under $30 million. That's less than half the price of an F-35. The unofficial hope? To flood the sky with loyal wingmen so cheap that losing one stings less than losing a tank of gas. It's a radical shift, an acceptance that quantity can and often will trump individual quality when backed by smart software. The beauty of the CCA concept lies in its modularity. You can slot in precisely the mission package you need for the task at hand. Need to peek behind enemy lines? Equip it with an electro-optical turret for reconnaissance. Got a jamming mission? Pop in an electronic warfare pod. Or if you need to bring the fight, its internal bay can carry a pair of AMRAAMs. The CCA's advanced AI handles the grunt work, precise formation flying, optimizing fuel consumption for maximum endurance, and executing defensive jamming sequences. Meanwhile, the manned quarterback, The human pilot sitting safely in an F-35 or the next-generation NGAD fighter focuses solely on strategy, the grand chess game. The theory is compelling. One pilot can now command a wolf pack of perhaps 4 autonomous jets, potentially tripling their strike range without adding a single extra human to the risk equation. This isn't just about extending range. It's about extending a pilot's cognitive reach and combat effectiveness exponentially. Need a decoy? No problem. You program the CCA to squawk like a full-blown bomber on radar, intentionally lighting up enemy SAM sites and drawing their fire, allowing manned aircraft to slip through undetected. Need a missile truck? Load the drone with standoff glide bombs and let it sprint 700 nautical miles ahead of the main force to release its payload, hitting targets deep behind enemy lines. Or perhaps you need a forward sensor. Push the CCA 200 miles ahead. Let its radar map ground targets. Then beam that crucial data back via low probability of intercept data links, ensuring the enemy doesn't even know they're being watched. The drone never asks for overtime pay, never needs a pension, and certainly never writes a tell-all memoir. It simply executes its mission, efficiently and relentlessly. It's not just the U.S. Air Force either. The Navy is playing the same game with the MQ-25 Stingray, an unmanned tanker designed to extend the combat radius of carrier air wings to beyond 700 nautical miles. That's enough to keep those multi-billion-dollar carriers safely outside China's coastal missile bubble. A critical strategic advantage. Across the Atlantic, Britain's Royal Air Force calls its version the Lanka. The ambitious Franco-German-Spanish team labels theirs remote carriers. Whatever the logo, whatever the national flavor, the job description remains identical across the board. Send machines first, keep humans farther from the metal storm. This global convergence on the loyal wingman concept underscores a fundamental shift in military doctrine and an acknowledgement of the changing realities of modern air warfare. AI in the cockpit autonomy, my friends, is the secret sauce here. Current rules of engagement still rightly require a flesh and blood finger on the trigger. But the decision loop, that critical OODA, observe, orient, decide, act cycle, is shrinking so fast that tomorrow's air combat may well be decided in microseconds. That's where AI truly shines. Enter machine learning algorithms voraciously trained on millions of simulated engagements, absorbing every conceivable scenario. This software digests radar returns, infrared images, and electronic emissions in milliseconds, then recommends optimal counter moves before a human pilot can even finish sipping their coffee. It's not just faster. It's capable of processing far more data than any human ever could. Skyborg, the Air Force's flagship AI program, has already taken to the skies aboard a Kratos XQ-58 Valkyrie. And during a pivotal 2022 test over California, the algorithm didn't just perform, it excelled. It autonomously rerouted the drone when a simulated surface-to-air site lit up, popped defensive decoys, and still arrived on station to deliver its mock payload, all within 3 seconds of detecting the threat. Human overseers merely watched, observing the AI's flawless execution. The code acted decisively and effectively. This wasn't just a demonstration. It was a glimpse into a future where AI handles the immediate, life-or-death tactical decisions. Of course, critics worry about a Terminator with wings scenario, and it's a valid concern we shouldn't dismiss lightly. Engineers, however, counter with 2 crucial guardrails. First, the software is task-specific. It can plot missile avoidance, calculate optimal attack vectors, and identify threats, but it absolutely cannot declare war on humanity. Its intelligence is narrow, focused on combat tasks. Second, weapons release still requires human consent via a secure satellite link, though the military candidly admits that the latency in such a link may one day prove too slow for hypersonic engagements, forcing difficult ethical and operational choices. For now, AI is the ultimate co-pilot, an invaluable assistant. Tomorrow, it may very well be the pilot, making decisions at speeds humans simply can't match. And here's another game changer. It's incredibly cheap to train. Replicating a single F-35 flight hour in a simulator costs a staggering 40 grand. Replicating 1 million AI sorties. That costs little more than the price of electricity. These algorithms learn from every virtual dogfight, every real-world mission, every adversary radar signature they encounter. They improve exponentially with every iteration, never forgetting, never tiring. Humans, by stark contrast, graduate training with a finite skill set, one that can erode under the immense stress of combat. In a data-driven world, where performance is paramount and learning is continuous, the learning curve overwhelmingly favors the machines. This isn't just an advantage. It's a paradigm shift in how we develop and deploy combat expertise. Swarm tactics in the Ukraine laboratory. If one drone is good, 100 is a strategy. And 1,000? That's an overwhelming force. The Pentagon's Offensive Swarm-Enabled Tactics Program, or OFFSET, envisions clouds of quadcopters numbering up to 250, each no bigger than a pizza box, saturating enemy airspace. Individual units within the swarm are designed to be expendable. It's the collective mass that wins the day. Algorithms dynamically allocate targets on the fly. Drone A suppresses anti-aircraft guns, Drone B drops a grenade into a radar van, and Drone C live streams the damage back to commanders in real time. No individual swarm member knows or cares if it returns home. Their purpose is collective mission success. This represents a fundamental shift from protecting individual assets to leveraging the sheer power of distributed, interconnected systems. Ukraine, unfortunately, has become the world's first large-scale, real-time swarm laboratory. In October 2022, a wave of commercially sourced racing drones, each costing a mere $600, descended on Russian artillery parks. Operators, often sitting in basements 30 kilometers away, steered them using low-resolution video feeds. The result? A staggering 32 pieces of tube artillery disabled in one night, for less than the price of a mid-range sedan. Russian troops, caught off guard, responded with machine guns on tripods, a desperate, almost futile gesture. But bullets cost more than drones. The economic exchange rate is brutally lopsided. Defenders spend $2,000 in ammo to swat a $600 threat, and the drones just keep coming. This asymmetric warfare capability allows even less sophisticated adversaries to threaten expensive military assets, forcing a disproportionate response. Now, scale that concept up to jet-powered platforms, and you get the loyal swarm. Imagine a C-130 Hercules releasing a pallet of 50 jet drones, each cruising 250 miles, each communicating via a resilient mesh network. You lose half to enemy fire? No big deal. You still have 25 reaching their aim points, causing havoc. Compare that to a traditional strike package. 4 F-16s, 8 highly trained pilots, 3 tankers, and the political headache of writing condolence letters if anything goes wrong. Swarms trade quality for quantity and win by sheer arithmetic. It's a numbers game where the odds are stacked against the traditional defender. Electronic jamming? Swarms anticipate it. When one drone loses its GPS signal, its neighbors immediately share their positioning data, seamlessly maintaining the swarm's integrity. If the mesh network is severed in one area, individual units default to preloaded area maps and radar-based terrain matching, rerouting and continuing their mission. Jamming one channel simply forces the swarm to reroute through another, like water finding cracks in a dam. The only proven countermeasure so far is kinetic. Large shotguns, Gatling guns, and other drones acting as interceptors. Israel's Iron Dome can stop rockets, a formidable feat. But stopping 200 golf cart-sized aircraft arriving simultaneously? That's a geometry problem that outruns even the fastest interceptor reload times, presenting an almost insurmountable challenge to traditional air defense systems. Manned-unmanned teaming in action. Picture this. An F-35 pilot, call sign Nova, cruising at 35,000 feet over the Taiwan Strait, the vast expanse of the Pacific shimmering below. Inside her helmet visor, 4 friendly icons, 2 loyal wingman drones and 2 reconnaissance UAVs, hover like holograms, extensions of her will. She speaks a command, calm and precise. The AI parses her voice tone, interprets her intent, and issues precise waypoints to the drone quartet. The drones, silent and deadly, sprint 150 miles forward, sensors cold, radars off, listening, waiting. Minutes later, the swarm illuminates the tactical picture. An enemy destroyer, 2 frigates, and a mobile missile launcher nestled ominously on Lashan Mountain. The battle space, once a blur of potential threats, is now clearly defined. Nova never touches her stick. Her fingers dance across a touchscreen, tapping an icon labeled Engage Air Defenses, then confirming the command with a quick, decisive thumbprint scan. She watches, almost detached, as the drones split into pairs. One element climbs aggressively to 50,000 feet, drops its glide bombs that ignite rocket motors mid-flight, screaming down at Mach 5. The second pair skims the ocean, popping electronic decoys, spoofing ship radars, creating a chaotic symphony of false targets. Anti-air missiles launched in desperation lunge at ghosts, wasting precious ordnance. By the time defenders reload, the real weapons have arrived, a cloud of miniature cruise missiles punching through hangar decks, turning a billion-dollar warship into a burning wreck. Total human input for this devastating multi-layered attack? One fingerprint. This isn't just about efficiency. It's about unparalleled precision and reduced risk. This isn't just some PowerPoint fantasy either. This is the future being built today. In 2023, the Air Force ran a classified war game replicating a complex Pacific scenario. Blue forces fielded 100 manned fighters and 300 CCAs. Red forces mimicked a layered anti-access bubble, designed to keep them out. Over 14 simulated days, the manned-unmanned team achieved a staggering 241% increase in targets destroyed compared to an all-manned force. Even more critically, human casualties dropped to near zero. The deciding factor? Drones soaked up 78% of all incoming missile shots, acting as expendable sponges, protecting the invaluable human assets. This force multiplication effect, combining the best of human strategy with machine execution, fundamentally changes the calculus of conflict. The Navy is rapidly copying the formula. Next-generation FAXX pilots won't just fly. They'll carry drone controllers in a side console, directing up to 6 unmanned aircraft per mission, transforming them into airborne tactical commanders. Marines, always at the tip of the spear, want swarms to escort their V-22 Ospreys into contested landing zones, jamming enemy communications and striking targets before rotorcraft even arrive, clearing the path for troops. Even special operations teams are experimenting. A single operator tosses a pocket-sized quadcopter into a village, the drone laser spots a compound, and a loyal wingman jet 60 miles away releases a small-diameter bomb. The loop from sensor to shooter closes in under 30 seconds, a speed that was unimaginable just a few years ago. This tight integration of surveillance, targeting, and strike capabilities fundamentally reshapes how missions are executed, making them faster, safer, and more effective. The global race, USA, China, Russia, the United States may have coined the CCA acronym, but make no mistake, China is writing the check. And they're doing it with a speed and scale that demands attention. Beijing's loyal wingman entrant, the FH-97, debuted at Zhuhai 2022 with specs that eerily mirror American prototypes. A 1,500-kilometer combat radius, an internal bay capable of carrying 8 precision weapons, and an advertised unit cost under $15 million. State media, ever the propagandists, boasted that one assembly line alone could build 100 fuselages per month. Even allowing for the usual propaganda padding, those numbers hint at a mass production capability unseen in Western plants, suggesting a deliberate strategy to achieve affordable mass on an unprecedented scale. This isn't just about technology, it's about industrial capacity and strategic intent. Russia, cash-strapped but undeniably imaginative, fields the S-70 Okhotnik B, a formidable 20-ton flying wing powered by a derivative of the Su-57's engine. Videos show this stealthy drone launching from the same runway as manned fighters, clearly hinting at integrated tactics. Yet crippling international sanctions are starving their access to critical sensors and microelectronics. Moscow's build rate crawls at a mere 2 aircraft per year. The Kremlin, however, compensates with a quantity of ideas, even if not hardware. Doctrine released in 2023 openly recommends using jet drones as bait, luring Ukrainian SAMs to reveal their radar signatures for subsequent attack by anti-radiation missiles. In practice, Russia's drone losses in Ukraine far outnumber production, highlighting the brutal attrition of modern warfare. The Okhotnik B airframe is formidable, no doubt, but the assembly line, tragically for them, is not. Europe, caught between rising powers, hedges its bets with 2 rival programs. The British-led Team Tempest integrates CCAs into a future combat cloud, emphasizing an open architecture design. This approach allows Swedish, Italian, and Japanese partners to seamlessly plug in their own bespoke drones and systems, fostering collaboration and interoperability. Meanwhile, France, Germany, and Spain pursue the Future Combat Air System, FCAS, envisioning remote carriers launched from next-generation fighters, a similar concept with a different political flavor. Political squabbles over work-share and industrial leadership keep timelines fuzzy. Yet both camps agree on one overarching goal: avoid buying American forever and maintain a sovereign defense industrial base. And it's not just the major players. Middle-tier powers are sprinting to stay relevant, recognizing the democratizing power of drone technology. Turkey's Bayraktar Kizilelma, a stealthy drone designed to operate from short-deck carriers, completed its first carrier landing test in 2023, an incredible engineering feat accomplished without the need for expensive catapults. South Korea's KUSFC prototypes fly in formation with FA-50 trainers, practicing coordinated missile launches, building critical operational experience. Australia's MQ-28 Ghostbat, co-developed with Boeing, has already flown in 3 variants: reconnaissance, electronic attack, and loyal wingman. Each iteration arrives in months, not years, a pace impossible in traditional fighter programs. This rapid iteration, enabled by embedded manufacturing and agile development, is truly revolutionary. The global race we're witnessing today uncannily resembles the 1950s jet boom, only it's happening at an even more accelerated pace. Then, every major power fielded a supersonic fighter within a decade, transforming air power forever. Now the barrier to entry is significantly lower. Advanced composite airframes can be milled in weeks. The real currency, the true determinant of power, is software. A nation that masters autonomy algorithms can leapfrog one that merely owns aluminium plants. Expect future air wars to pit American AI against Chinese AI, each commanding swarms built on different continents, but running the same lethal mathematics, constantly evolving and adapting. This is not just a technological competition. It's a race for strategic dominance. Section 7. Cost exchange ratio. The hidden war modern warfare at its core is an accounting exercise, a brutal ledger of costs and benefits. Consider this: a Patriot missile, a jewel of air defense, costs $4 million. Shooting it at a $600 quadcopter and off-the-shelf hobby drone is economic surrender after 6,000 engagements. You've bankrupted yourself defending against a nuisance. The Pentagon's answer to this asymmetric nightmare is the affordable mass mantra. Build drones so cheap, so numerous that adversaries must either waste their precious high-end interceptors or simply accept the damage. The magic ratio they're aiming for? 20 to 1. If a drone platform costs 1/20th of the munition needed to kill it, defenders inevitably go bankrupt first. It's a cost imposition strategy designed to bleed the enemy financially. Let's look at a concrete case study. In 2023, the U.S. Navy ordered 120 disposable jet drones from Anduril Industries. The unit price? A relatively modest $300,000 each. These aren't fancy reusable systems. They're designed for 500-mile one-way missions, each carrying a potent 500-pound bomb. Now imagine 40 such aircraft, a relatively small swarm attacking a guided missile destroyer. To stop them, the ship fires perhaps 30 interceptors, averaging $1 million apiece. The exchange rate here is telling: $12 million to defend versus $12 million to attack. Rough parity for now. But what happens when you double the swarm to 80 drones? The destroyer's vertical launch tubes run dry, its magazine exhausted. Some attackers survive, slip through the cracks, and a $1.8 billion warship risks mission kill by robots costing less than a Ferrari. This isn't just a battle. It's an economic squeeze play. Economists call it a cost imposition strategy. Military planners with a glint in their eye simply call it victory. The same math scales up dramatically to strategic bombers. A B-21 Raider, a marvel of stealth and technology, costs roughly $700 million. A loyal wingman drone built with similar stealth characteristics but without the life support systems, the complex cockpit, or the immense training pipeline for a human pilot, that could run around $70 million. Now imagine 10 drones for the price of one bomber, each capable of carrying the same payload. This fundamentally changes deterrence equations, making saturation raids economically feasible. Foes must assume such raids are affordable, and these assumptions in turn drive budgets, and budgets ultimately drive politics, even logistics. The often overlooked backbone of warfare bows to this ratio. Drone bodies are typically constructed from aluminium and carbon fiber, materials you might find in high-end mountain bikes or sports cars. Fighter fuselages, by contrast, rely on exotic titanium forgings and complex alloys sourced from a handful of global suppliers, often with fragile supply chains. In a protracted war, drone supply chains can regenerate faster, adapt quicker, and scale up with far greater agility than manned aircraft pipelines. In short, the potent combination of autonomy plus affordability doesn't just create tactical advantages, it equates to strategic stamina, a critical factor in any long-term conflict. Section 8. Ethics, accidents, and the kill chain. Handing lethal decisions to Silicon raises profound, often unsettling questions. What happens, for instance, when pattern recognition software, in its relentless pursuit of a target, misidentifies a school bus as a missile launcher? Current U.S. policy, a deliberate ethical firewall, still requires a human in the loop for weapons release. Yet that loop latency, the time it takes for a signal to travel via satellite, can exceed 10 seconds, long enough for a target to duck under cover or for a critical opportunity to vanish. Engineers, ever pragmatic, propose on-the-loop oversight. AI recommends a strike, the human has a 5-second window to veto, otherwise consent is assumed. Critics, understandably, label this as moral outsourcing, a dangerous step towards fully autonomous killing. Accidents, unfortunately, already litter the record, stark reminders of the fallibility of even advanced systems. In 2020, a U.S. MQ-9 Reaper operating over Libya lost its data link, glided silently into a neighborhood, and tragically killed a family of 5. The subsequent investigation blamed fuel starvation. The drone lacked self-destruct charges deemed too expensive at the time. Cost versus ethics collided in a single devastating crash site. Future designs now include programmable scuttling charges in civilian model transponders, but no algorithm, however sophisticated, can eliminate Murphy's Law entirely. The human element, even in remote oversight, introduces its own set of unpredictable variables. International law, ever the tortoise in the race against technology, limps far behind. The United Nations talks earnestly of banning lethal autonomy. Great powers, citing distrust of rivals and national security imperatives, stall and obfuscate. Meanwhile, export controls tighten, but often too slowly. The Missile Technology Control Regime now classifies drones capable of 500-kilo payloads and 300-kilometer range as Category 1, the same as cruise missiles. Smaller allies, desperate for affordable deterrence, protest, arguing they need these tools, not diplomatic handcuffs. The result? A burgeoning gray market, with middle-tier vendors, Turkey, Israel, UAE, selling armed drones with fewer strings attached, accelerating proliferation and complicating global stability. Expect the debate to intensify, not diminish, as AI accuracy relentlessly improves. When algorithms achieve 99.9% target recognition, when they demonstrably outperform human fallibility, public tolerance may well shift from an adamant never autonomous to a pragmatic better than human. Until then, however, every drone strike, precise or not, will be scrutinized frame by frame on social media within minutes, dissected by armchair analysts and human rights activists alike. Militaries that master transparency, that openly address ethical concerns and potential mistakes, will shape policy and build public trust. Those that hide behind classification, that obfuscate incidents, will face #tribunals and a steady erosion of legitimacy. The moral high ground is as crucial as the tactical one in this new era of warfare. CTA 1, mid-roll. If these trends feel like sci-fi speeding toward reality, then you absolutely need to hit subscribe and stay ahead of the curve. Drop your predictions in the comments below. Will China mass-produce the first carrier-capable drone? Or will American software dominance keep the edge? Like the video if you learned something new, and please, share it with that friend who still thinks dogfights are the future. What this means for the fighter pilot Hollywood painted pilots as lone wolves, callsign mavericks twisting throttles in sunset skies, epitomizing courage and individual skill. Tomorrow's aviators, however, will look less like maverick and more like airborne mission managers, perhaps even akin to esports captains, orchestrating complex engagements from a networked cockpit. Their role shifts from direct control to strategic oversight. Training syllabi across air forces already reflect this profound shift. Undergraduate pilot school now adds mandatory classes on AI tasking, data link protocols, and the ethical implications of swarm command. Physical G-tolerance tests will undoubtedly remain, but cognitive bandwidth, the ability to process vast amounts of information and command multiple autonomous agents simultaneously, will matter far more. Can a candidate track 12 autonomous agents, manage their mission parameters and react to emergent threats, all while sipping oxygen at 40,000 feet? If yes, welcome to the cockpit of the future. The career timeline, traditionally a slow, arduous climb, is also compressing dramatically. Traditionally, a fighter jock peaks at age 40, perhaps as a squadron commander having accrued thousands of flight hours. Drone operators, by contrast, can command critical sorties at 22, master captain-level tactics by 25, and orchestrate theater-wide swarms by 30. Rank structure. A sacred cow in military hierarchies may well flatten. Experience will be measured less in flight hours logged, and more in algorithm iterations mastered and successful AI-human collaboration missions. A 25-year-old major directing 200 drones could hold more combat punch, more strategic influence than a 45-year-old colonel in a single, exquisite F-22. It's a generational shift in leadership and influence. Still, human intuition remains prized for one singular irreducible reason: ambiguity. Algorithms excel at pattern matching, at executing predefined rules with blinding speed. But war, as Clausewitz famously noted, is messy, unpredictable, and inherently human. A pilot's gut feeling, honed by years of training, by observing unpredictable human behavior, by understanding the nuances of the battlefield, still spots the trap, the anomaly, the unexpected move that falls outside the dataset. The future is therefore inherently hybrid. Humans set the objectives, machines execute the intricate details. Dogfights, the romantic image of aerial combat, will become exceedingly rare. Dog herding, the orchestration of robot swarms, will be routine. The very nature of career risk also shifts dramatically. Instead of the immediate visceral danger of cockpit death, pilots face the insidious threat of desk burnout. PTSD rates among drone operators now tragically match those of infantry units. The guilt of lethal mistakes, even when the cockpit is a trailer in Nevada, lingers, often silently. Air forces are hiring psychologists at scale, copying tech firms' wellness programs. Recognizing the unique mental strain of remote warfare, the pilot of 2035 may log off a sortie, bike home to their suburban house, and help their kids with homework, yet carry the profound mental load of a sniper who never leaves the suburbs, grappling with the remote consequences of their actions. Section 10. Obsolescence of the old guard traditionalists. Those clinging to the glory days argue that fifth-generation fighters will stay relevant through continuous upgrades. New radar, new jamming pods, new stealth coatings. They believe these platforms are simply too advanced, too capable to be phased out. History, however, disagrees, often brutally and swiftly. In 1914, admirals clung desperately to their battleships, symbols of naval power. By 1918, submarines, once considered ancillary, were deciding sea lanes and threatening global trade. In 1940, cavalry units, steeped in centuries of tradition, charged tanks, often with catastrophic results. By 1945, tanks were carrying infantry, fundamentally altering ground warfare. Technology inflection points don't just upgrade legacy platforms. They erase them, often faster than nostalgia can save them. The same unsettling principle applies directly to air forces today. When a $30 million drone armed with sophisticated AI can reliably kill or incapacitate a $120 million fighter, the budgets will inevitably vote, and they'll vote decisively. Congress may fund 2,000 F-35s on paper, driven by political considerations and constituent jobs, but future defense chiefs will face a stark, unavoidable choice: buy 100 manned jets, or invest in 1,000 loyal wingmen that collectively can deliver 3,000 combat sorties per day. Legislators, often defending jobs in their districts, will fight to cut drone orders to save traditional factories, until an adversary proves the concept in combat, unequivocally. Then and only then, do budgets flip overnight, driven by the cold, hard reality of battlefield effectiveness. Expect retirement notices, not just for individual aircraft, but for entire fleets once considered untouchable. B-1 bombers, once the spearhead of long-range strike, already marched to the boneyard. F-15Cs, legendary air superiority fighters, are slated to follow. Even the mighty F-22, a symbol of American air dominance, is slated to shed half its inventory by 2030. Their replacement? Not a newer, shinier fighter, but a distributed family of systems. Manned command jets orbiting safely, flanked by expendable machines that do the bleeding, that absorb the risks. The sentimental attachment to cockpits, to the image of the lone warrior, will last one electoral cycle, perhaps two. After that, the spreadsheet, the cold, hard economic and strategic calculus, wins conclusion. So here's the undeniable takeaway, the core truth reshaping modern conflict. Air combat is no longer a contest of shiny aluminium airframes piloted by daring individuals. It's a contest of data links, of adaptive algorithms, and of ruthlessly efficient cost exchange spreadsheets. Autonomous drones extend human reach to unprecedented distances, soak up risk that no human should have to bear, and collapse the price of power projection, making it accessible and scalable. They turn $600 garage builds into strategic threats, capable of overwhelming and damaging far more expensive assets. They transform billion-dollar destroyers into nervous targets constantly on edge. Fighter pilots aren't vanishing. They are evolving, transforming into network commanders who orchestrate robot swarms the way conductors shape symphonies. One gesture, 100 instruments playing in perfect, lethal harmony. The nations that master affordable mass, that embrace the blistering speed of AI decision-making, and that navigate the complex waters of ethical transparency, will own the skies of 2035 and beyond. Those clinging to Top Gun nostalgia, to the romanticized image of individual heroism, may find their runways lined with immaculate, unflyable relics, beautiful museum pieces perhaps, but ultimately useless. They will serve as stark reminders that in war, economics and innovation always trump romance. CTA 2, end screen. Which country do you think will field the first fully autonomous drone carrier? Drop your bet below, smash that subscribe button for weekly deep dives on the future of warfare, and share this video with anyone who still thinks dogfights decide wars.